I want to begin the sensation and perception videos with an important discussion about something that has quite a bit of generality in psychology. And that begins with the 1830s when Weber, or as it's sometimes pronounced, Weber, discovered a basic law that translates your perceptions of something like weight from the physical stimulus. So let's consider a simple demonstration experiment. Here, for example, is my cell phone. If I put my pen on top of my cell phone, I can tell the difference that the pen makes by adding a small amount of weight to my cell phone. However, if I pick up our textbook and hold that in my hand, and then I add the pen, I can't feel any difference at all from the addition of that weight, even though it's the same weight. So what does this mean? Well, this means that our senses are operating as a proportion. You need a certain amount of increment as a percent. If you add 10%, let's say, of the weight, then you can tell the difference. Now, the pen might be 10% of the weight of the cell phone, but there's no way it's 10% of the weight of the textbook. Hence, add the pen to the textbook, I can't feel the difference. Try this yourself. What this leads to is some pretty interesting things.
Now here's a graph which shows the Weber-Fechner law. Fechner added stuff to Webner's story, and so we often include him. And on this axis right here, you have the stimulus intensity plotted in equal weight increments. Every ounce is an ounce. On this axis here, you have your perceptions plotted, your sensations. And it's clearly not linear, because as you get to heavier and heavier weights, in order to be able to tell a difference, you need more weight. If we didn't have that, our perceptions might look like this, and if this was the limit of our perceptions, our sensations, we would be cut off right here.
This nicely bending curve gives us great advantages in mapping our perceptions onto significant changes in the environment. We often measure things in inches when they're on our scale, but you would never measure a building in inches. A building that was 40 stories tall and one that was 40 stories and 1 inch would appear to be the same height to us, and that's a good thing. The quantitative precision of the Weber or Weber-Fechner law also did something else for psychology. It really showed that our mental life, our sensations, our perceptions, could be measured in a way that was quantitative. And this helped psychology become a science. In fact, the idea that you needed a proportional increment is really the same thing as an important mathematical principle called a logarithm. We won't go into that here, but the similarity gave a lot of credence to psychology. Another group of people went off and studied color vision and made very elaborate, very precise laws about how colors mix together and how perceptions change when they do. But let me give you one example of how this might be used by you. Suppose you're watching television and your mother comes in and says, "Please turn the TV down some." And you're watching it at a volume of 40, which would be pretty loud. If the TV set is linear, you're going to have to reduce that by 4 if it turns out that the just noticeable difference, or Weber-Fechner law, requires a 10% change for you to get the person to understand that something has changed. On the other hand, if you're watching it at 20, not so loud, but maybe your mother's about to make a phone call and she asks you to turn it down, then you might only have to turn it down by 2, because 2 is 10% of 20. So we can figure a lot out about what people think from this precise law. And then the question is, can we extend it to other things in sensation and perception or beyond? And that would really make the science of psychology.